today we're going to be talking about distance, rate, and time. And distance, rate, time problems are like very common in like many different math competitions. And the AMCA also definitely tests distance, rate, and time. So for distance, rate, and time problems, like these kinds of problems are actually like not that hard, but like they can be tricky if you're not like familiar with how to do them. So before we talk about what this basically means, let's just basically first go through some basic definitions. So I'm sure most of us probably already know the general ideas of what distance, rate, and time are, but just as a quick overview again, like distance is basically how far something travels, right? Like if an object moves like 5 meters or like 10 feet or something like that, then like that's a distance, right? So like 5 meters or like 10 feet. Like these are examples of like distances, like how far something travels. Uh, and then the next term is rate. So rate, a lot of times you might sometimes see it as also speed. So you might see like in a problem, instead of saying something like this person's rate is this, they might say this person's speed is this. Just note that rate and speed mean like the exact same thing. So we probably all know what speed means, right? Like speed is like how fast something is going. So like examples are like 5 meters per second, or maybe like 10 miles per hour or something. And the last one is time. So we probably all know what time is, right? Time is like basically like 2 seconds is an example of time, or like 5 minutes is an example of time. Like we all know what time is. So distance, rate, and time, these are like the definitions. And there's actually a very important relationship between these three quantities. And that is like distance is always equal to rate times time. And this you might often see as abbreviated as D equals RT. And this equation is like very important. Like when you're solving distance, rate, and time problems, this is essentially like one of like the only equations you'll need to use. Like sometimes you might have to use some other like algebra skills, but like pretty much in all of these distance, rate, time problems, like this is like the only equation that you really need to know, which is why like these kinds of problems are not like hard, but they can be tricky with setting up the equations and things like that when things get more complicated. And yeah, so for example, if a person was walking at like 5 meters per second or something, and they were walking for like, let's say they were walking for at 5 meters per second and they were walking for like 10 seconds, then the total distance you would just do 5 times 10. So they would be walking a distance of 50 meters. So this equation kind of gives distance in terms of rate and time. If you wanted to solve for the rate, you can easily like just divide by time on both sides. So you can say rate is equal to distance over time. You can also solve for like time and say like time is distance over rate. So these are like the important equations, but just like kind of remember and understand distance equals rate times time, because then you can just derive like these two from like the first one. And let's talk about one more important thing about these three quantities, which is something called units. So a lot of the times in math problems, like math problem writers, like the people who write the problems are not nice people. So they're gonna try to think of ways to like trick you. So one of the most common ways they'll try to trick you with distance, rate, and time problems is by giving you things in terms of different units. So for example, it's possible that you might get some problem about like a person is walking at like let's say you're driving a car, right? Let's say a car is moving at like 60 miles per hour, and you want to know like what is the distance traveled after, let's say, like 120 minutes. So in this case, like we could just use distance equals rate times time, but we can't do it directly. Like we can't just say, oh, I'll take the 60 because 60 miles per hour represents like a speed, right? It's a rate. And I'm going to just multiply it by 120, which is a time. Like you can't do that because here they gave it to you in miles per hour, but the time we're given is in minutes. So we can't really multiply these together because that doesn't really make sense. So like it's important when you're doing these kinds of questions to always make sure your units match up. So if we were to solve this problem, we know that this car is traveling at 60 miles per hour. And in order to solve the problem, we would have to convert 120 minutes. We know that 120 minutes like is equal to 2 hours, right? Because there's 60 minutes in 1 hour. So we're just going to convert 120 minutes into 2 hours. And the reason this is now fine is because we have hours here and we have hours here. So like the units now match up. So we can like remove the hours. So 60 miles times 2, that'd give us 120 miles. And yeah, so that's like just a quick like brief explanation on why units are important. Like if you see that, they give you different quantities in different units, like they give you the rate in miles per hour, they give you the time in minutes, for example. The first step before you do anything is to convert everything to the same units, because if you don't do that, then you're probably going to get the wrong answer, which is bad.